For this project, we made an evolutionary algorithm music generator. Essentially, we implement that evolutionary algorithm to create an initial population of songs and then have a function that runs over it over time and do some crossover mutation and eventually get a song that sounds really good. What I'm going to do is I'm going to play a song first to show you what it looks like. Essentially, you can select a key or an octave. Let's just select B flat major. The low octave sounds the best, so we'll do that. But we also have a game component to it, so the notes will appear from the right side of the screen, and when they line up with the middle, with the A, S, and D keys, you have to press those respectively, and then each note that you hit, you'll get 100 points. So let's just demonstrate that for now. Okay, I'm not going to show the entire song because they're pretty long. Essentially, each song has a different section, so it starts with an intro, and then the chorus plays the first time, then you have a first verse, the chorus plays a second time, you have a second verse, and then finally you end with the chorus again. But that's the game component of it, so you can see it in action. And as you can probably see, I wasn't losing any points for missing any notes. But the main core of this program is the evolutionary algorithm, so I have a brief diagram to kind of go over and explain it. So each of our groups originally made Markov chain algorithms for our ProcJam projects, but for this one we decided to combine our ideas and then overlay an evolutionary algorithm on top. So this is a general diagram of how evolutionary algorithms work, and so you need to have some form of initialization of a population of songs. So we chose to have 10 songs in our population, and they're procedurally generated with the Markov chain-based algorithm that we made before. So that's still being used to initialize the population. And then you have to have some sort of selection, so you need some sort of fitness function to run on each song and give it a certain score. And what we do is we base those scores off of the chord progressions in the songs, which is taken straight from the Markov chain-based algorithm. So here we have a diagram of the different major and minor chord progressions that are common in music theory. So if one of these chord progressions is met, say you're in C major and you generate the third note, which would be E, then if you were to generate the sixth note, which would be A, it would be a pretty high score because you can see right here the chord progression is quite common in major keys. So any of these conditions that are met will have a higher score in that case, whereas if I generated a 3 and then a 2, for instance, it might be a lesser score. Because 6 would be higher score according to this chart. And so what we do is we add up all those chord progressions between each note and then average them all out to get a final score for the entire song. And what we do is out of the population of 10 songs, we pick the highest scoring one, and for the crossover, we take the lowest scoring section of the highest scoring song, so whether that's the intro, chorus, verse 1, or verse 2, and we randomly swap that out with the same section, so whether it's chorus, intro, or one of the verses, and we swap that with a random song in that population. So we swap those two. Then we do another 2 crossovers with 2 random songs in the population, so that gets us to a total of 6 songs, 3 crossover pairs. And then finally, we just use the Markov chain-based algorithm to procedurally generate the last 4 songs. And that will be our population. Now, each time we make the new song, there's a 1 in 10 chance of a random pitch in that song being mutated, and that will also affect the song as well. And so then we have our new population after 1 iteration, and then we rerun the selection. So we do this loop. In our algorithm, we do it 100 times. So you're constantly making new populations from the old one. After you run that 100 times, then finally you get the highest scoring song of that final population, and that's the one that gets played. So then when you go here and you play your song, this song is the highest scoring one out of those 100 iterations.